Okay, so this is our last installment for solving equations with properties, and today we're going to be working with inequalities. Okay, so something I want you to think about as far as why inequalities work the way they do or why they have so many answers, things like that. Okay, so in Georgia, you must be at least 15 to get your learner's permit. Okay, that is a very specific statement, meaning that 15 is the youngest age that you can be. Okay, so 15 would be a true answer. So would 16, 17, 18, however old you're going to go. You could also have all the little decimals in between. You could be 15 and a half. You could be 15 and 3/4, meaning like 3 months from your 16th birthday. You could be any of these decimals in between. You could be 15 years and I don't know, whatever 100th would be of 365 days, probably like 3.5 days, whatever it is. But you can have all those decimals in between, but you have to be at least 15. Okay, so 14.99999 is no, you're not allowed to do it in Georgia as far as a permit. The soonest you can get it is on your 15th birthday. So you have to be at least 15. Okay, so another one for the Liberty County High School prom, and I don't know if this is true or not. They may have decided to go with more tickets now, but there can be no more than 250 tickets sold. Okay, so what that means is you can sell 250 tickets. You can sell 249, you can sell 200, you can sell 150. Now, for something like this, you would not allow decimals, right? Because you can't sell half a ticket. But you also cannot sell, and again, I don't know if this is true or not. They may have made it a different number. It's just an example. You cannot have 251 tickets. So 250 is the highest amount you can have. Okay, now both of these can be expressed as a inequality because I don't want to sit here and list every possible correct answer. So at least 15 looks like this, that your age has to be greater than or equal to 15. Okay, no more than 250 tickets sold looks like this. Again, because I don't want to sit here and list everything from 0 to 250. Okay, so that's why inequalities are important, because sometimes you have situations where you have more than one right answer, but you don't want to sit here and list all of them out. Okay, so we're going to be practicing. We're going to practice writing some, we're going to practice graphing, and then we are going to practice solving. Okay, so as a reminder, when you are graphing, okay, you are going to use, oh, don't you love technology? You're going to use an open circle, okay, for less than, and I'm going to go ahead and write that out for those of you who have kind of a hard time remembering which is which, or greater than signs. Okay, so less than or greater than. And then you use a closed circle for less than equal to, greater than equal to. Okay, and again, less than it or equal to is how we read it. And this is greater than or equal to. And that's a very big difference, because for the less than or equal to, greater than or equal to, you're allowed to actually be the number that is represented in your inequality. And for the less than or the greater than, you're not allowed to be that number. So if I said you have to be less than 18 to, I don't know, go to Sam's Treehouse on Post. Less than 18 means that you cannot, on the day you turn 18, you cannot go anymore. Okay, less than 18. So you could be 17 years and 364 days, but you can't be 18, right? So it could not actually be that number. So big difference as far as when we graph them and when we write them. Okay, so we are going to graph these just to make sure you're comfortable with which one is less than and which one is greater than and which way it goes. And I know a lot of middle school teachers will tell you, okay, well, the arrow, the pointy part of your inequality points in the direction that you shade. Well, that only works if your variable is on the left. If I wrote this same statement like this, okay, that is the exact same statement. This says x is less than 3. This says 3 is bigger than x, greater than x. They mean the same thing, but the arrow is not pointing in the correct direction. So if you're having an issue with it, try to come up with some numbers that will make that statement true. If x has to be less than 3, or if 3 has to be bigger than x, give me some numbers that 3 is bigger than, right? Give yourself some numbers that you can put on the graph to help you. So first off, we have a less than symbol or a greater than symbol. So that is an open circle at 3. That shows that 3 is not actually allowed in our problem. And this says x is less than 3. This says 3 is greater than x. That means I need numbers that are smaller than 3. So they have to go this way. And again, if your variable's on the left, that's fine. Yes, the arrow is a good way to check it. If it's not on the left, you're going to probably need to give yourself some numbers to make sure you graph it in the correct direction. Okay, so x is greater than -1. Again, greater than or less than, open circle, at -1. I'm not allowed to be that number. Okay, x is greater than -1, so that would be numbers like 0 to 5, whatever it is. So I'm going to shade in the direction of my true answers. And this is actually how we show this on a graph, because there's, an infinite number of answers that are bigger than -1 if you include all the decimals and everything else. All right, x is greater than or equal to 4. So close circle at 4, because I'm not allowed to include 4 in my answer. And x is greater than or equal to 4. So some numbers bigger than 4 are 5, 10, 100. So that's the way I'm going to shade. All right, so x is less than or equal to -6. And again, the pointy end does point at the piece that's smaller. So -6 with a closed circle, right, since there's an equal to. And some numbers less than -6 are -8, -10, -100. That's the way I need to go. Okay, so just as a reminder, again, you are going to be graphing your answers when you're solving inequalities. All right, let's try writing some inequalities from a graph, just to make sure we've got this backwards and forwards. Okay, so number 5. All right, I've got an open circle right there, so I know I'm not going to have an equal to, right? So it's either going to be less than or greater than. Okay, my numbers, the numbers that I'm shading, are less than 13. So what I want has to be less than, smaller than 13. Okay, closed circle. So again, less than or equal to, greater than or equal to, since it's a closed-in circle. The number I'm looking at is 7, and everything that is shaded is bigger than 7. So that means my inequality, right, has to be bigger, open side for the bigger than 7. And 7 has to be smaller than all the other numbers that are shaded. So again, pointy end always goes at the smaller number. And I know some teachers used to tell you the gator eats the bigger number. It works the same way. The pointy end goes toward the smaller number. The open mouth goes towards the bigger. Okay, closed circle again. That means less than equal to, greater than or equal to. All right, I'm at -18, and the shade is getting smaller. Remember that the bigger the negative number, the smaller you are. If you need to think about it like debt, you have less money, right? If you owe somebody $20 than if you owe them $18, right? You're actually further in debt. All right, so x has to be less than or equal to -18. All of my numbers have to be smaller than -18. All right, last one, open circle. Again, greater than or less than, no equal to on that one. That's 10, and all my numbers are getting bigger, right? So that means the numbers that I want have to be bigger than 10. Okay, so now we are going to actually start solving equations with this. Okay, so we're going to write our properties just like we were doing with the regular equations, and we are going to graph our answer at the end. Okay, so same thing as before. The first step is always your original equation. All right, so we treat these the same way we treat equations as far as we do add, subtract, multiply, divide. There is only one exception, which we're going to get to on example 2, just so you can make a note to yourself. So for right now, ignore the fact that this is not an equal sign. We're going to treat it the same way. I need to either divide everything by 2, right? Or I need to subtract 7. I'm going to go with subtracting 7 just because if I divide by 2, I'm going to end up with that fraction, that 7 over 2 that I don't want. So subtraction property of equality. And because I am adding or subtracting, I'm automatically going to go down here. I know I have to combine like terms. Okay, so 2x plus 7 minus 7, 12 minus 7, showing the same thing on both sides. Combine like terms means I'm going to have 2x and nothing else. That's a 0 pair. And 12 minus 7 is 5. Okay, so still have to isolate the variable, get x by itself. 2 is multiplying the x, so I have to use the division property. And if I am multiplying or dividing, I am going to have to simplify every time. All right, so I'm going to show that I am dividing 2 on both sides. And I'm going to have either 5 over 2 or 2.5. You are not allowed to put 2.5. Okay, either answer as far as that will be fine, but no mixed numbers. All right, so now we need to graph it. Okay, so I'm just going to slide right under here. And I'm going to graph it. Now, I do not expect you to start your number lines from 0. There's no need to, especially when some of your answers are going to get really, really big. What you probably want to do is put your answer in the middle and then give a couple of numbers on either side. I have a decimal, so I'm just going to put 2 and 3, since I know that's between that, and then 4 and then 5, and let's just say 1. Okay, if my answer was 12, I would still put 12 in the middle and I'd only put a couple of numbers on either side. There's no point in writing an entire number line. Okay, so to graph it, remember, we have a open circle at 2.5. Okay, so that's about right there. And what I'm asking for as far as my answer is that all of my answers have to be less than 2.5. So less than 2.5 means 1, 0 going into the negatives. Okay, and that is the way it should look when you're done. All right, so number 2. All right, so original equation. All right, so same goes. We're going to ignore the fact that it's an inequality for right this second. We're still going to solve this using our properties. All right, and we had a problem like this when we were doing solving equations. Remember, if you want to subtract first, remember what you are actually subtracting. You are subtracting 5 over 4 from both sides. Okay, so be real careful with that first. Number 2, you have variables on both sides of this. Okay, so this is kind of a difficult problem to do. We're going to have to do several different things. I don't want to add, I could add 2/4 x to both sides. That would be fine. I could do that. And then I would have all of my x's on one side. I'm going to go ahead and multiply first because I don't want that fraction there. That gives me kind of a problem when I'm trying to move things around. So I'm going to go ahead and use the multiplying property first. Just because I don't want that 4 there. I could separate this out and make this negative 2/4 x plus 5/4. That's fine. Then I could add 2/4 to both sides. because it's got all the x's on it. That's also fine. If you want to go through that, go ahead. Again, we have calculators that help us with decimals and fractions. It's fine. All right, and since I am multiplying, I have to make sure I simplify. All right, so if I multiply by 4 on both sides, all right, so I'm going to end up with, remember, those 4's just cancel. 2x plus 5. Okay, and then x times 4 is just 4x. Okay, so that looks a lot better as far as the kind of answer I would need to, or the kind of problem I would want to work with. That looks a little bit better. Okay, so remember how we talked about I don't like dealing with negative x's if I can help it, right? So I'm always going to move the smaller of the two numbers. So that means I'm actually going to add 2x to both sides. Why? Because that is a negative, right? There is an actual sign in front of it, so it's a negative. So that means I need to add 2x to both sides. All right, let's go ahead and write my property. I'm going to use the addition property of equality, and that means I am going to combine like terms. All right, combine like terms. All right, so negative 2x and positive 2x is 0, so that's just 5. And then 4x plus 2x is 6, okay? So I have one last step because I still have something attached to my x, right? That 6 is multiplying it, right? Anything in front of a variable without a symbol has to be multiplying. So that means I have to use the division property, and then I'm going to have to simplify. And then simplify. All right, so I'm going to divide both sides by 6. All right, so 5 over 6. And again, if you want to make that into a decimal, go ahead. I don't because I know it's going to be a really yucky looking decimal. So I'm just going to leave that as 5 over 6. All right, and then we need to graph it. Okay, so to graph it, again, we need to make a number line, put a few numbers on it so that we know which way this is going. All right, so 5 over 6, if you remember your fractions, that's less than 1 but bigger than 0. So how about 0, 1, 2, 3, and I'll put a negative 1 over here. Okay, so again, it doesn't always have to start at 0. You just need to put a few numbers around your answer. So I'm not looking for exact. We know 5 over 6 is closer to 1 than it is to 0, and it is a filled in circle. Right, so I'm just going to put my dot right there. Okay, and so then we got to figure out which way to shade it. Again, we can't go by the arrow because the X is on the wrong side. You know, it's on the right, so the left. But I can read this based on my inequality. This says that 5/6 has to be less than all the rest of my numbers. Right, so I need numbers that are bigger than 5/6 because 5/6 has to be smaller than that. So bigger than 5/6 would be like 1, 2, 3. So it's going to get shaded in this direction. All right, I'll do a couple more just to make sure you're good. Okay, same deal with our properties. It's always the original equation to start with. Okay, so again, I could multiply by 2 first. There's nothing wrong with that. I would have to multiply 1 to all 3 pieces, which is fine. We can do that. Or we can go ahead and add 4. Again, I'm going to go ahead and go with add 4 just because I want to multiply the least amount of pieces possible. And if I'm adding, then I am combining like terms. All right, so 1/2 x minus 4 plus 4. 8 plus 4, same thing on both sides, right? And combine like terms gives me 1/2 x, and 8 plus 4 is 12. Okay, so we talked about this when we were solving equations. Yes, that 1/2 is multiplying the x, and normally the inverse of multiplying would be dividing, but this is a fraction, so it's a special case. So we don't actually divide by fractions, we multiply by the reciprocal. So we're actually doing the multiplication property, and then we are going to simplify. Okay, so I'm going to multiply by 2 on both sides. And what I'm going to get is that x, because 2 times 1/2 is 1, is greater than or equal to 24, 12 times 2. Again, going to graph it, put 24 in the middle, 25, 26, 23, 22. Again, you do not have to start your number line at 0. Okay, so close circle at 24. We know that already because the number's there and the line's underneath. All right, so x has to be greater than or equal to 24, which means all of the answers that I want have to be bigger than 24. So all the answers that are bigger are on the right-hand side. All right, last one, and I've purposely included something that has variables on both sides. And I am also purposely going to show you what happens when we have a negative, because there is one exception to the rule on inequalities, and that is when you are multiplying or dividing by a negative. Okay, so original equation. All right, so I'm actually going to subtract 5 from both sides. And that means I'm going to combine like terms. All right, so 9 minus 3x minus 5x, and 5x minus 5x plus 15. Now I'm doing this on purpose because I need you to see what happens when we have a negative. Sometimes, now on this case, if I added 3 to both sides, I would get a positive, which means I wouldn't have to do anything special. But sometimes you don't have a choice. You're going to have a negative and you're going to get stuck with it. So you need to make sure what you're doing. All right, so combine like terms. Negative 3 minus 5 is negative 8. Be real careful. That is not 2 because you are starting off at a negative 3 and subtracting 5 more. Okay, and then 5x minus 5x is 0, and that's 15. All right, so now I am going to go ahead and subtract 9 from both sides. So I'm doing the subtraction property again. Remember that you do not want to take both things off of one side of the equation. You want to take one of each piece, okay? Since I moved the 5, I got to move the 9, right? Different pieces from each side. So that means I'm also going to combine like terms. Okay, so 9 minus 8x, and then 15 minus 9. Okay, so combine like terms, I'm going to get negative 8x, and 15 minus 9 is 6. Yes, 6. Okay, had to think about it. All right, so last step, since my x is still not completely by itself, right? I have a variable attached to it, which means I have a multiplication statement that I need to deal with. Okay, so here's where the interesting part comes in. Multiplication property of equality, and then I have to simplify. That is the rule. Okay, so you need to put a note to yourself somewhere. When you multiply or divide by a negative number, You must flip the inequality. So basically, if it's the pointy end is going to the left, the pointy end is now going to go to the right. You have to flip it around. Okay, so I'm going to divide by -8 on both sides, and then I am going to simplify this. Okay, so -8, -8. I'm going to flip my inequality. So x is now going to be greater than or equal to instead of the less than. Okay, and I can simplify 6 over -8. I can either leave it as a fraction or I can make it into a decimal. If I simplify the fraction, it ends up being -3 over 4. Okay, there we go. The whole fraction is negative. All right, so I need to graph this. Okay, and take a look, please, that my answer is negative. So we've got 0, -1, -2, +1, +2. All right, so -3/4 is somewhere between 0 and -1. Okay, and I need a closed circle. So somewhere between 0 and -1. Okay, and then all my answers, all my correct answers, all my x's need to be bigger than -3/4. So I have to go to the positive side. Okay, and I'm done. And we are done solving with properties. See you next time.